All right, so the couple M acts in a vertical plane and is applied to a beam oriented as shown. Determine A, the angle that the neutral axis forms with the horizontal, and B, the maximum tensile stress in the beam. Well, let's think about the angle that the neutral axis, I don't want this color, that the neutral axis forms with the horizontal. Well, we see that the moment is in the horizontal, so let's say with the moment vector. Now, I want you to understand what this vector means. See how there's a line like this and a line like this? Well, think about it. This is where your thumb points, and this is where your fingers of the right hand curl, right? So the plane will be perpendicular to the vector, to the moment vector, the plane of bending. Now, this is not necessary to know for the problem. I just wanted you to understand that. And now, let's think about determining the angle of the neutral axis. Well, we've been told, and actually we've been told this in class, that this should be our y-axis, and this should be our z-axis. So now that we have this, I want to find things related to this axis. And we know these are principal axes. We know these are principal axes because there's a plane of symmetry here. This plane is the same as this plane for this cross-section. And there's another plane of symmetry about the z. So these are also principal axes, which is good to know. Which is good to know because it's going to make our math a little bit easier. Now, I want you to look at how this is 90 degrees and this is also 90 degrees. So if this is 70 degrees and the other part must be 90 degrees as well. Sorry, 20 degrees. So this angle right here is 20 degrees, which means the angle of the moment vector with respect to the x-axis, the positive x-axis is, and that's what we call theta in our formula, is 70 degrees, right there. So it's a little tricky when they give you that angle. They're trying to trick you. Don't let them fool you. All right, so now we know that this is unsymmetric bending. So there's going to be two moments. There's going to be a moment with respect to the z-axis, so the distance from the z-axis is y divided by a moment of inertia about the z-axis, and that's negative. And then we have another one that's positive, which is going to be the moment y, moment about y with a distance z from that axis, and so we find the moment of inertia about y. Now if you set that equal to 0, so if you set, this is for part A, if you set sigma x equal to 0, and I just want to show you where the formula comes from, you have it on your equation sheet, so you don't necessarily need to derive it every time. But it's nice to know where things come from. So you'd have mz times y divided by iz, and I'm bringing mz to the left-hand side of the equal sign, equals to myz over iy. Okay, so now that you have this, let's look at mz and my. Well, we can decompose the vector of this moment in these two vectors. So this would be m, and we'll express it in terms of theta. So m, what would this be in terms of theta? It would be m sine of theta, sine of 70 degrees. You can visualize it if you put it right here, and you put the other one right here, and m cosine of theta for the one on the left, on the z-axis, and it's in the positive z-axis. So what we'll do is the one on the z-axis is m cosine of theta over I z y, and m sine theta z over I z. Now the m's are the same and they're not 0, so we can cancel those out. And now what we can do is rearrange this equation, and we'll get y is equal to iz over, sorry, not I put two iz's. I didn't want to do that. This is iy. So this is going to be iz over iy, all of that times Sine of theta over cosine of theta, that's the tangent of theta, and that's equal to z. Well, if I bring the z to the other side, we have y over z is equal to I z over I y tangent of theta. And what is y over z? Well, y is going to be this length right here. Z is going to be this, so it's tangent of theta. So we can express this as tangent of theta. Not tangent of theta. This is going to be tangent of phi. And so I guess the confusing part is, why would it be a different angle? And I don't have a good answer for you right now. But this is where the formula is coming from, and I'll get back to you on this. Why different angle? And I guess in this case, well, they can't be the same thing because they're asking us to find it. So they are going to be different. The neutral axis is going to be something... it's going to be somewhere else. It's going to have a different inclination. So that's how you find your phi. So let's find IZ and IY and the tangent of theta. We know what theta is. We just found it. So to find IZ, I'll just write it down. So look up IZ and IY for S6 times 12.5. S6 times 12.5. So if you go to the Appendix E of the book, Appendix E, what you're going to find is you're going to find this S, and it's going to be S. What page is this? Page A25. You want to make sure it's in U.S. customary units. And now you're going to scroll down to S6 times 12.5. And you're going to look for the column that says IX, which is, it's the equivalent of your IZ. They just called our Z-axis, they called it X. So you'll say IZ is equal to what? IZ is equal to 22 inches to the fourth. And then we've got one more, IY. Well, what is that equal to? IY is equal to 1.8 inches to the fourth. Okay, so now that we have that, we can actually find our phi. Our phi is going to be equal to the tangent inverse of IZ over IY tangent theta. And so the tangent inverse of 222 inches to the fourth divided by 1.8 inches to the fourth times the tangent of 70 degrees, that's going to give me an angle. Now, think about y and z. It's going to be an angle with respect to the z-axis. So it's going to be some angle right here, phi. So that's not what they asked us. They said the angle between the neutral axis and the horizontal axis. So we'll have to think about that for a second. So now if I take on my calculator, what I'm going to do is I'm going to do the tangent inverse of 22 divided by 1.8, all of that times the tangent of 70 degrees. Make sure your calculator is in degrees, and I get 88.29 degrees. 88.29 degrees. Now, to answer the question, we have to find, well, let's say this is a little bit bigger. Theta is a little larger. So now that we've resolved everything, we don't need to see all of these things. We just want to see our z-axis and our y-axis. So this is my z-axis, this is my y-axis. I know the moment has an angle. So this is a theta. And then phi is like, with respect to the z-axis, is this big. This is phi. So we want to know this angle right here, the angle that the neutral axis makes with the horizontal. So we'll call that, I don't know, call that gamma. And one thing that's that you have to be careful of is the idea of subtracting one from the other. So you want to subtract phi minus theta. So we're going to say that gamma is equal to phi minus theta, where theta is this. And so that's going to be 88.29 degrees minus theta. And theta is going to be 70 degrees. So 70 degrees, that's 18.29 degrees. Okay, and this should be the answer for part A. Now, I'll leave you here, and we'll do part B in the next video. I'll see you there.